Here's a couple of trickier rational function examples. And what's different about this one is, see how as I'm approaching positive 3 from the right and from the left, they're both going up to positive infinity. This is acting like the function, the toolkit function, that's acting like 1 over x squared. Okay, so that's what we got to keep in mind when we're doing the vertical asymptote for that one. This other the other vertical asymptote, at x equals -3, is doing what asymptotes, those vertical asymptotes typically do, approaching from the left, pushing from the right. Though this one might be, because if you think about what the reciprocal function looks like, reciprocal function looks like this. As I'm approaching from the left, I'm heading to negative infinity. As I'm approaching from the right, it's going to positive infinity. So this has been flipped. So I know there's going to be that leading coefficient will probably be negative. Okay. So where do we go from here? So I'm seeing a vertical asymptote at x equals -3. So that's going to go in the denominator. We make it +3. And then I see the other one at x equals +3. So, but that's behaving like the x squared, so we'll square that. Let's see, I'm seeing a single 0 at x equals 2. So x minus 2 is the 0. And let's see, so then this would be a, if I FOIL this all out, I'm going to get an x over an x cubed, so that tells me the horizontal asymptote will be at y equals 0, and that's what this is looking like is happening. So that looks like I'm okay there. I don't have to do anything more about that. So the only thing I got to worry about is this vertical intercept, the y-intercept of -2. So I've got some a number that I'm going to multiply by, and this is how I'm going to get that a number. So I'm going to replace, because that vertical intercept is a coordinate 0, -2. X is 0 and y is -2, so f of x equals -2, and I don't know what a is, but if I substitute in 0 here, 0 here, and 0 here, that's going to give me -2 over 3 times 9, right? Because -3 squared is 9, which is going to give me -2 over 27. That's times a. That equals -2. Well, if I take the reciprocal and multiply, I get a equals 27. So I'm thinking that this is 27 times x minus 2 over x plus 3 times x minus 3 squared. I'm going to go graph it and check. So here's what I got out of Desmo, and you know, my initial guess about the a term being negative was wrong. Looking at this, so I guess we did it right, and I hope so. I hope it helps with that one. So what's tricky about this one, and I point this out because I ask a question like this on one of the quizzes or exams, and because you're going to see this all the time in calculus when you start calculus. See how this graph has a hole at x equals 4? The only way that happens if I have the same factor in the numerator and the denominator. It doesn't exist at positive 4, so I know there's going to be an x minus 4 in the denominator, but if I just leave it that way and not worry about it, that would be a vertical asymptote. So the way I get the hole in there is I put the same factor in the numerator. So that takes care of that problem. I'm also seeing at x equals -1, there's a vertical asymptote, so I'm going to write x plus 1, and I'm going to put that in the denominator. That way I get the vertical asymptote going on. I'm seeing 0 at x equals 2, so I'm going to put a x minus 2 as a factor in the numerator. I'm seeing a horizontal asymptote of y equals 1. I see I've got the same degree in the numerator and the denominator, so I guess a will be 1. And let's see, I haven't taken care of that y-intercept is 0, -2, so I gotta see what's happening with what I've got written so far when x equals 0. When x equals 0, I'm going to get -2, and the x minus 4 factor, I mean, I'll substitute it in, but they're going to cancel off. So I do get -2, so I don't need any other additional stretch factor. So this is how you deal with that when you have a hole. Not that really hard, other than making sure you have that common factor on the top and the denominator to take care of that hole. Okay, so I hope that helps you do that one too. There's some more of these at the end of section 3, section 4, if you want to do some more. They're out of the book.